So the first type of landslide that we're going to look at is the slump. So the slump is going to be a rock or soil sliding along a curved slip plane. So when you think of a slump, you're going to think of a curved slip plane, or you're going to think rotation, okay? So in this case, slump is, it slumps as blocks per se. So as you're seeing in the diagram on the right, you have this curved slip plane underneath, on top of which you have the slump blocks. So you have one on top of here, then a second one on top of here. So these are going to be the slump blocks. The side here from which they detached is called the head scarp. And then all the material at the bottom where the blocks are pretty much going towards is going to be called the toe. All that material that has slipped and is now at the bottom is the toe. Okay? So you're seeing in this image on the left, the head scarp is this feature right here. And then underneath at some depth is going to be the curved slip plane underneath these blocks. You're seeing one of the slump blocks right here, potentially another one right here. And somewhere off in the image where we can't see is going to be the toe at the bottom. You're also seeing a profile view of how this looks. Again, you're seeing that curved slip plane. Each of these is going to be a slump block. The head scarp is up here, and then you cannot see the toe, but you're expecting the toe to be somewhere over here. So actually, we have our own example of a slump occurring in Boise right now. In the Terra Nativa, I guess, area, you have this landslide that has been occurring since 2015, a slump type of landslide. So water is coming from up there, and because of the diversion of the water from the road, the different channels that they wanted to take, they've let the water run through the left and then the right side of the road. In this left side part, there's a lot of clays that are very expandable, if you would, with the intake of water. So because clays themselves have a lot of porous space, whenever they are saturated with water, that water will remain in the pore spaces and make them very, fluid in a way. So because that water that used to run on the road is now diverted to this, I guess, left side part of the road, those clays are getting very saturated and are getting very weak. And so I'll show you the time lapse of what's occurring with that Terra Nativa landslide. So it started in 2015. I believe that area was built in 2015, and then you're starting to see that just 1 year later, you're getting a pretty major displacement, and you're seeing the headscarp right here. You're seeing this is one major block, and then there's another major block on the other side of the road, which is where most of the houses actually got damaged to a certain degree. The second type of landslide that we're going to talk about are falls. So in this case, a fall is going to be the free fall of material, and for the most part, that material is going to be big rocks or boulders. So it can be, again, a rock fall, or it can be just soil or debris fall itself. But in that case, it's still going to be material, although smaller. It's still just going to be falling, not necessarily with moisture incorporated within the material, like the slump was, for example. So, for example, in this case, this is where you're going to get your hard rock kind of slope. So you're going to get the free face, as you're seeing right here, and you're gonna get the talus at the bottom, which is that material that has fallen. Or in the picture, you get your free face right here, and you get that talus on the bottom right there. So now I'm gonna show you some examples of that. This is gonna be a video, which is kind of cool, actually. Let's see. So that card barely made it, which is pretty amazing to me. So lucky, and they're like, okay, I'm just gonna back up. But anyways, actually I think this is sped up. So let me play it for you a little slower. So you can sort of see the overall effect. Check that out. Oh, it's crazy. Near hit. Oof. Anyways, but you see that that major block got got eroded from the free face up here, and it pretty much tumbled all the way down to the road. So how it got displaced, you may ask, from that cliff face is probably by the action of weathering. And so that is very common. The type of weathering that you can see there is very common here in Idaho and in locations where you got fairly heavy winters. So in the springtime, you get frost wedging, which is basically weathering that occurs when ice, when water creeps into different fractures. Then the water freezes with cold temperatures in the winter. As water freezes, it expands into ice, right? Ice tends to, well, not tends to, ice will occupy more volume than water. And then once that ice thaws, once it gets a little bit warmer, it will thaw. And then because it expanded within the crack, it's going to make a little bit bigger of a crack every time. And so if many years happen or go by and the crack becomes bigger and bigger, that crack is going to destabilize the slope in which those boulders used to reside. So that's easily how you get many of these boulders to fall down. So this happens a lot actually in the Banks-Lohman Road during the springtime again. So if you ever see such a thing happening, it's not really rare per se, and many a times that causes many of the potholes that you see in the road as well. Here's another example of obviously the aftermath of a rock fall. You see that that massive boulder got detached along with smaller stuff probably, and it just completely damaged this house. You see in this case that car was not so lucky as the one we saw in the video, but again, massive boulders detaching from what probably is a cliff face, a free face from that hard rock slope. Third type of landslide that we have are slides themselves. So sliding is going to be the movement of a coherent block, and as opposed to slumps where you had kind of like a curved surface underneath the slump blocks, now we have a plane on top of which the whole soil, the whole upper part is moving and sliding down past it. So again, we're going to have this plane as you're seeing here, and everything on top is going to move downward. So it can be a rock slide like you're seeing here, but it could also be a soil slide, soil slip, debris slide, earth slide as you're seeing. So that usually happens at the regolith and bedrock boundary. No, sorry. The regolith is going to be basically any unconsolidated material that sits on top of the bedrock. So regolith is going to be composed of all the soil horizons, which we will look at next week. So it's going to be any material that kind of resembles the bedrock at the bottom, and then on top of that you're going to get closer to soil as we know it, and closer where you get organics like root and animal like decaying animals, if you would, or decaying leaves and plant matter on top of that. So anything that is on top of the bedrock tends to be the material that is moving when you have this type of landslide, which are, again, slides. So we have here a few examples of these slides, and they're all very classic, if you would. You're seeing pretty well here also a headscarp like we had for the slumps, but in this case, this whole bit is moving downwards instead of kind of having slumps that are in a curved surface. There is a plane underneath that we cannot obviously see because this is not a profile picture, but there's going to be a plane on top of which all of the top of the bedrock part is moving downwards. Same thing here. You see this is going to be the headscarp, and you kind of almost see the plane over here, on top of which all of this material has moved downwards. Same thing over here, very straightforward. And then this is the also landslide in Washington, which you saw an image for, I think, the first chapter. And so this is a very complex landslide because it's a slide on the top, as you see the headscarp, and then this is all one big plane. But then once you get to this, I guess, elevation right there, sorry, that's my dog, you have a slump as well. So you have a curved kind of surface right here, and you have blocks that are sliding past, and then a toe right here. So it's kind of a two different type of landslide slide, if you would. So the Japan example that we saw at the beginning of lecture is a type of slide. So it's very similar to this bottom one, as we're seeing, in which the trees are staying pretty much still. They're staying standing for the most part, because again, the soil on top of which they're sitting, on top of which the roots are placed, is all moving as one cohesive block, rather than, splitting up into smaller blocks like the slumps did. So the fourth type of landslide that we're going to look at are flows. So flows are going to be the movement of unconsolidated material. So they're going to differ from slides and slumps, because slides and slumps usually move as, blocks or basically blocks of the whole material. In this case, the flow is going to have each particulate separate from the other one. And although they are all moving downwards in the same direction, there's going to be, a lot of different chunks. So it tends to be a lot more erratic and more dangerous in a way than do the slides or the slumps. And there are different types of flows. You can have a flow as creep, earth flow, debris flow, or avalanches. So we're going to describe those four in the next few slides. So this example right here is an example of creep, which is very slow moving, very slow flow. So the flowage, as they say it, is going to be in millimeters per year. You're not going to see the change, within only a week or two. And then there are certain signs that we can look for to tell us that there is creep ongoing. So some of those signs may be that the fences are tilted or poles are tilted. Fences tend to be a very good indication. In Idaho, in places where there's no urbanization whatsoever, a good sign of creep is also curved tree trunks, as you're seeing over here. So because trees want to stay upright for the most part, whenever there is creep underneath them, they have to constantly accommodate. So they start curving their trunks at the bottom and then, moving upright the rest of it. Another sign for creep is going to be this kind of soil ripples or soil kind of lumps, if you would, that we're going to see in a little later in a few pictures. So here's an example of that fence that is now tilted. So it's very obvious in this case that there has been creep ongoing. Okay, so here's just another image showing you the tilted poles and the curved trees. And it's showing you that the whole soil is moving very slowly, but it is moving downwards. Okay, so here you are seeing this kind of terrace sets, if you would, that are usually formed in Idaho by grazing animals, and not just in Idaho, I should say, pretty much anywhere in the planet where you have grazing and you have kind of a weakening of the soil itself. But they form by the grazing animals that as they, trump around the landscape, they debilitate the soil even more, so that it'll create this kind of steps, if you would, in the landscape. But overall, by the weakening of the soil, by the animals, from the animals, and by the soil moisture, this soil is moving very slowly, but it is moving as creep. And then again, here we see the curved trees. This could happen in Idaho. This picture probably isn't in Idaho, given the type of trees, but it's very common to see it in different mountains in Idaho. You see that the trees kind of resemble a pistol butt, so if that helps you, remember that, then by all means use it.